everybody, and welcome to Rocket Lasso Live, episode 15. How is everyone doing? Start getting those questions put together. We're going to need them. How is everyone doing today? Yeah, things are going well over here. I guess let's pop open. Let me full screen this thing and pop this open just as your weekly reminder that Half Res is coming up. So head on over to halfres.com. You can click get your tickets, and that's going to hop you on down here. And discount code wise, I meant to look this up ahead of time because I just cannot remember. It is you can get 20% off if you use the early bird code, which is halfres 2025 early bird. I'll copy and paste that into the chat because why not? Let's go. Boop. That's not the right button. Paste. And YouTube. Paste. And the website. Paste. And the website. Paste. Yeah. Halfres. Halfres.com, everybody. So yeah, come on over. We've got all the speakers all set up here. We've got the main speaker, Donnie Bauer from Chicago. He's going to be speaking, so very excited about that. Yeah, besides that, we're going to be tackling questions in Cinema 4D, but I definitely have, let me make sure YouTube is going because I don't see any chat on YouTube. If somebody's on YouTube, say hello so I can know that the stream is actually working over there. Where's the window? It seems to be streaming. Okay, cross my fingers. And okay, one other exciting thing is another one of the Rocket Lasso tools has gotten released into Cinema 4D. So if you have a Cinema 4D subscription of any sort, then you should now have another one of the Rocket Lasso capsules in there. And I was going to do a demo about it. And this one's pretty exciting. It might be one of my favorite ones that we made just because it's going to open up a lot of really cool opportunities. Now, as I go through here, if anybody has any questions or want to see any particular demos of it, please let me know. But let's go into the asset browser and I'm going to search for the word Rocket Lasso. And as always, you can see we've got this giant collection of all these different example scene files. But if we scroll on down, you're going to see there's this new one called Interconnect. And this is actually a concept that I've had for a while that I wanted to make. And we are going to build it as a plugin and sell it as a plugin. But now we've just built it in as a capsule for Maxon. So that's exciting. And I've got some example files, but let's just start demoing through the tool itself and show you exactly what it does. So to begin with, I'm going to make a plane. If I hit NB, you can see here's all the different parts that make up the plane. And let's make a second plane. So I'm going to grab this upper one. I'm going to pull it further up. Okay, now let's make an interconnect. So here is interconnect. This is a generator object. So you can see here's interconnect. And what it wants you to do is to drop geometry as a child. So we have to drop in both of these as children. And the instant I do, you're going to suddenly see that the geometry is consumed and we've got a whole bunch of straight lines. Now, what is happening here? Well, it is interconnecting between the objects, essentially index to index. So what this means is I can move this plane around and I get all these splines that are interconnecting directly between the two. But this opens up a lot of really exciting possibilities. Think of all the things that we can model like using a technique like this, and we can feed in additional objects. I can make another copy and make duplicate there, make another copy, and let's move this up and hit T for scale, scale that down. And we keep on making more of these and kind of guiding it around however we like. So that's pretty cool. And then if we go into the interconnect, we have a lots of different settings. Let's move on in. I'm going to say don't be closed. And now you can see how these are, traveling straight through. We can change our spline type, or actually there's a tangents section. Let me give us a little more room. There's quite a few parameters on this one. So if we click on tangents, we can say we'll create a tangent for all objects, and you're going to see that we get these curves. Now, I probably want to invert my direction here, so I'm going to say Y minus, and now you can see they look a little bit more smooth. So grabbing, you can start thinking of this a lot like maybe some of the different lathes and lofts and sweeps. It's got a similar kind of pedigree to what that is doing. So let's grab an extra plane here and maybe I can move this one to the center, and I'll hit T for scale and scale that out. Now you can see I'll scale further out from that one. But there are so many different things that we can do with this tool. So let's go and look at some of the basics. In fact, let's keep everything super duper clean, go through step by step. I'll make a disc shape and let's drop it in, and I'll make a second disc shape and we'll scoot it up into the air. So one of the first, well, we can do a selection. I'm not going to demo that selections are boring, but you can limit it to a particular selection. Explode segments will become important, but right now we're interconnecting between the points. Now, I might not infrequently make a duplicate of the object so I can kind of see the original and then what we're dealing with. Let's turn off tangents for a little bit, and I'll also just immediately invert the orientation. So, if I were to grab this disk, you'd see that every single point is getting interconnected, and I'm grabbing this duplicate of the disk so you can actually see them moving along. An alternative method we have is to interconnect between the polygon centers. So now you can see it's coming from the center of every polygon and connecting to the center of every polygon. Moving inside, we've got things like how do we deal, what's the count? So right now we have the percent, so I can return only a certain percentage of those. And then we've got a count, so I can change it to that and say, well, return exactly 3 of them, or return more. Now I'm actually overloading it right now. There's more than can fit, so it's actually duplicate lines, but we'll get into that in a little bit. But yeah, this percentage, use highest if there's a count mismatch. Very important. If I were to grab this upper disk here and put a whole bunch more segments, you see I've got more segments, but they're still all interconnecting. But they're interconnecting using a different algorithm right here. You can see it says, how do we deal with the surplus? And it just repeats the index. So right now, we are taking whatever had the highest number of points, and it has to find a partner, even if it's repeating the partner. But if I say use the lowest percentage, it's actually taking every single point or polygon center from the object with a lower count and then finding a pair for that. So this upper one doesn't get everything complete, but the bottom one did. Let's go back to highest. And it's actually a little bit since we made this one, so I'm trying to remember the super basic demos because there's a lot of fun things we do here that we're going to go through. Let me show off shuffle in there. I mean, we can do some of the basics still. So let me go and make all of these identical again. So we got a whole bunch of them. Other settings we have are something like step indexes. So you can see I can increase this, and it's almost like spiraling around because it's not matching to the perfect identical index. It's actually stepping along, and in this case, it's stepping along 4 to go further and further along. And then we've got initial shuffle, and that's going to rearrange the order. Now, actually, visually, this isn't going to look like much. If I crank this up, it doesn't look like anything changed, but something did change. The order of these has gotten randomized, but that'll be more important in a particular combination later. And then we've also got our shuffle indexes, and that's different than the initial shuffle. The initial shuffle means like both 1s became 13 and both 17s became 6. Shuffle indexes, if I say all objects, you can see that every index has gotten completely randomly shuffled on every object instead of them all being shuffled together. So now you can see we got all these random connections in between these 2 objects. Now, again, all of these we can continue. I'll make another duplicate. And again, I just want to be able to show you what the object looks like. So I'm making a copy outside of it. I can make another copy. I can move this up, and you can see that they do continue to be connected, but it's a different connection. That is also randomly, that is randomized separately. Moving on, we've got shuffle, and you can actually do a percentage shuffle. So I can pull back on that. So you see all of them are perfectly aligned. And as I start increasing this, they're going to start shuffling, but they can only shuffle like a couple of units from where they are. So if I go all the way, complete randomness. But if we go a little bit, then nothing's connecting to the exact opposite one. They'll be connecting to, a little bit away, 25% of the points away, but not further than that. So again, pretty useful. Continuous connection we'll talk about in a little bit. I mean, the basic idea of that would be if I were to bring that duplicate back again and we scoot this over, these are actually continuous lines where whatever this line connects to there and then connects there, those are all, that's a constant connection, one spline. But if we say continuous connection off, it's not going to look very different, but now that's a separate spline and that's a separate spline. So they get to be like randomized in that way. We already looked a little bit at the tangents, and others, when we start kind of building actual visuals here, then the tangents would become more important. Actually, breakage junctions, continuous connection. I think I might be mixing those 2 up. Let's go and actually build something a little bit more fun here. Let's say, actually, I do like starting from that disk shape here, and I'll increase, but let's go and do something like make a text object. So here's some text. Let's just say RKT. Let's go and get ourselves a big old beefy font, which of course is going to be lemon milk. And center it. Let's go deeper. And now what I'd like to do is give this some pretty even subdivisions. This is all just working from polygons. So let's go and set this to something like 45 degrees. I'll set it to subdivided. We can increase that. We don't need nearly that many. And on caps, we could shift this to regular grid or Delaunay, something like that. Yeah, so giving us a couple extra subdivisions there. We could even subdivide the edge. We could also throw it into a volume. But anyway, now we've got a text object with all this extra geometry here. So let's interconnect these to each other. So I'm thinking I will make a duplicate of both so we can see the original and the copy. If I turn those off, it consumes them because you can't return geometry and the spline at the same time. Okay, so what are we dealing with here? I think we're mostly on defaults. I'm going to say don't shuffle the indexes. So yeah, here's pretty much defaults, except we're not in points mode. We're in polygon mode. So we are using the highest count, whichever one has a higher count, and then interconnecting between those. And this text object probably needs to go into a connect. Yeah, it needs to go into a connect. Because MoGraph objects, it's actually like a null with a bunch of different objects inside. So a lot of things don't see it. So yeah, now it's a connect. Now it looks like the way I expected. So now you can see that we've got a bunch of connections here and a connection to every single polygon that was on this text object. So a ton of connections. Now let's start making this look a little bit more fun. I'm going to change our tangents to be something like, well, you could say tangents on all objects. And then we've got these different modes, like what direction is it going to be? I'm going to say auto, and actually maybe regular normals will be fine. And now we got the tangents. So you can see I can increase the tangents, and now the tangents coming off that object are actually giving it kind of like this direction where they kind of shift off of it. Now, let's grab our disk shape, and I'm going to invert its orientation because that's just the way the normals work, is that we're coming from the norm of the object and continuing. But now you can see I've got this disk shape, and it is now random. Well, it's now very linearly connecting every one of its indexes. Let me grab both so you can see the visual. As I shrink this down, you can see we've got these connections that are traveling from one into every single polygon of the other object. But look at this. I can move this around and look at this super coherent connection that we have. We could make animations from this very, very easily. So lovely connections from there. Now let's see. I might scale these up to make that a little bit larger. And then just for fun, why don't I make a duplicate of that disk shape there, and I'll make a duplicate of it there. And this one, if I pull it up, then you see we've got this continuous connection going. This one I'll hit T for scale it way down, make a smaller pipe, and then we could rotate this around. So you can see I can add an additional control here. So everything starts from one organized thing, travels through this small point, and then connects onto the text. And keep in mind, at any point, I can grab my text here, and I can move that around as well. Okay, so having done that, let's go back into the interconnect and do something like decrease the total percentage of the connections that we're making. So I'll say, okay, decrease the number of connections. And you can see that we've made way, way fewer of those connections of the total, but they're all connecting to the very first polygons over here. And it does look cool, but what I would like to do is randomize those. So let's go and say, grab the initial shuffle, and I'm going to do a random initial shuffle here. So now everything has been randomized, and now you see that we only get occasional connections. We're now only making 6% of, or let's do 5% of the total possible connections. But because we did the initial shuffle, it is connecting to random polygons. So now we get these lovely connections going. Let's move down into our tangents that we're already creating here, and we can do things like randomize the strength. So I can make some of the tangents be stronger or some of them be weaker. And we can also randomize the direction a little bit. So if we go and take a peek at one of these coming out from the surface, you can see that normally that is going to be coming straight out from the normal of the polygon. But as I increase this, it can actually tilt off axis randomly. So we've added a whole bunch of randomness on top of that, but we're still making these connections. Let's grab these lower disks, and I might even pull this down. Yeah, so we get these lovely connections going in between. So now what do? Well, these are raw splines being generated. So why don't we do something like make an electric? Let's make an electric spline modifier, also a Rocket Lasso capsule, and we'll drop that as a child of the interconnect. I'll make it the last object. And now it is deforming that spline. So if I hit play, now we've got electricity automatically interconnecting between these objects. And these tools were actually designed to work with each other. Even when we made electric, like however long ago that came out, we knew we were going to be making interconnect. So you can see I can actually grab this and drag it along, and we get coherent lightning traveling between the two. Let's make the electric, just because this is such a large scene, I'm going to add extra displacement in, and let's lower our noise frequency so that, yeah, everything's a little larger of electricity. And I can grab my my blend here, and you see I can modify the blend to go all the way to the end, so it's actually still touching, but we got electricity all the way to the very tip. So yeah, all that electrical happening. We could, yeah, have these be more random, have those be more random. But yeah, now you can see we have this electrical effect traveling. Why don't we slow down that noise? Let's do like 10% there, but I'll give it a bunch of movement rate. Let's do negative minus 500, and I can see the electricity looks like it's traveling into the text from from whatever direction we want it to be. And this is just me going from one shape to another to another. We could be feeding any shapes in here that we like. Instead of doing these disc shapes, why don't we make a sphere? So I'll make a sphere. We're going to change it to be triangular, T for scale, get it pretty dang big. And I'll make a duplicate of it so we can still see the original. Actually, I won't do that because we won't be able to see anything. I'll drop that as the second child here. And now you can see that electricity is coming from all those outer parts of the sphere and then connecting down to where the text is. So I could scale that up or make more connections, make fewer connections. Even right now, I can go back into my interconnect and say, what percentage do we want? And we have this be a really small percentage, or you have it be a much larger percentage. We get a ton here. Now the electric spline is heavily subdividing those. So, it's going to go a little bit slower. Actually, we're such a large scale, I could probably reduce the step quite a bit. Yeah, so it'll speed up, even with all those lines. Okay, cool. So I don't want quite so many, so we'll lower that down. So now we go instant electrical effect layering on top of this. Raw splines that we can do whatever we want with. We can put this in the sweep. We could render this with Redshift or any third-party renderer. We could, feed it into any sort of geometry. Everything you do with splines. You know me. I love the power of splines, and this combines really well with a bunch of the other Rocket Lasso tools as well. So yeah, now we get all this electricity interconnecting however we like. And even here, it goes to, I could make a copy of that sphere and now scale up that sphere. Now you can see I've got one sphere connecting to another one. It's kind of invisible right now, but I could take it the second sphere and then, drag it down or drag it up. You see I'm just like art directing and placing all these anywhere I want to. So I could get some sort of spiral going. So yeah, but that's pretty cool. I'm going to keep this file open just in case we want to go back to that sort of rig, but let's talk about some other variations we might be able to do here. Do I have a specific rig I'd want to do on this? I haven't specifically done this type of rig, but I'm going to attempt to do something with a cloner. Why not? So we'll do a cloner. I'm going to make it linear. And actually, yeah, we'll do this separate like this for now. And then we'll intersect them. So here's a cloner, but if I put that into a connect object, the cloner is now being treated as a single piece of geometry. Don't weld. And now let's feed that into an interconnect. So let's search for interconnect and drop that inside. And we're not going to see anything because we're supposed to be connecting from A to B. But there's a very special setting in here, and that is explode segments. And that will make every separate segment behave as its own object. So if I turn that on, suddenly it's going to be acting as if we have 1, 2, 3 objects inside of it. So with that in mind, we can do some things like, let's grab our tangents. So I'll say, okay, let's do all tangents. And you'll see what the effect looks like right now is actually, it's a little bit hard to, let me make a duplicate of this. So yeah, it looks like the tangents are properly coming out from, I'm having trouble telling if the tangents are going in or, oh wait, I'm sorry. It looks like it's closed by default. So let's turn off closed. Okay, so now they're just coming out from, the geometry. And you see they go out, but then they're going to the inner. How do I explain this? Then the way the splines connect is they go out from the normal, from the positive normal, and they go in to the negative normal, and then out the positive normal and in the negative. And that way you can like art direct with that disc shape like I showed you. But now we've got these spheres, and the spheres are, we don't want this connection going on to the inside and then continuing on the outside. But we have an option where instead of the direction being based on the normals, the direction be based on absolute normals, which means they're always on the positive. So if I turn that on, you'll now see that all of these normals zoom out and then connect to the second one, and then they zoom out and connect to the third one. So now let's go and give these bigger tangents. I will randomize the strength of them randomly. Let's give it a bunch of random directions, so they're kind of tilting randomly. And then, let's go and randomize them. So I'll give them an initial random index. And then we don't need to return all of them. So we get some interconnections here. And do you remember a couple of weeks ago when somebody was asking about creating like those magnetic fields from planets? And I was like, oh, there's a tool coming out that I wish I had. And this is what I was talking about, is that we could do this type of thing. So we got this connection from A to B to C, which is incredibly powerful. Now we can go back inside of our cloner. I'll grab both of them just so we can see it, and I can make more of them if I want to. And let's see, what else might I want to do here? I mean, here's what's cool is all this stuff works in the context of MoGraph as well, especially we're in this connect object, but let me make a random. So this random effector is now going to be animated using noise indexed. And let's say that all the stuff can move quite a bit. So 555, 555, 555. So now if I hit play, you're going to see very fast. Let's grab the speed and drop it way down. Now you can see that all of these are moving around and they're interconnected, but it's working through the cloner system. Let's go and inside the interconnect, right now it's based on distance, but we could say there's an absolute connection. So now you can see I could drag this up to be absolute. Now you see that depending on their distance, it's not really stretching those out anymore. I think in this configuration, that looks a little bit better. So yeah, have those all drifting around. Now what I was going to do is grab these linears and say, don't do a linear connection. So now we've got a bunch of those moving around. And then we'll have each one scale up a bunch. So these will be stepping through. So we'll scale each one up, and maybe no random here. Maybe this won't be a nice visual. Yeah, well, I guess maybe if we change that to be, maybe we don't even need normal. So now they're all traveling through each other. And now if I grab my cloner and spin the clones, now you can see I have them each spinning around inside of that. Now we could go and turn the tangent back on again inside of Interconnect. We could say tangents. There's actually a mode called auto mode, and auto mode is just going to do almost like it's just like a cubic interpretation between them. That one's a little twisty. I'm not loving the way that looks, but the regular or the absolute are giving like actually pretty good results there. But you can see these now twirling around. We could make more clones there, have them spiral and spiral and spiral, just making kind of a crazy effect there that I wouldn't know how to make otherwise. Fezenko. This is, I think, only going to be 2025. Essentially, as we would develop these, we're always working in the newest version of Cinema, so they weren't backwards compatible. So yeah, keep that in mind. Anyway, these are interconnecting through a cloner, which is super duper exciting. Let's open up another file. Actually, okay, now we're going to go back to that text one. I know I wanted to stay this way for a reason. And actually, okay, yeah, we can't stay here. I'm going to turn this off, and you see now that we've got these lines, and they're, this is what they look like. This is just all lines with tangents. There is no displacement. We could change the interconnect to, show various things. But another tool we made that was designed to work with interconnect, even though we made, interconnects coming out now, and the tool I'm about to show, it came out like a year and a half ago. These were conceived of together. And the other tool that we've made that works well here is called Pulse. Now, Pulse is not the most artistically intuitive tool. This was made mostly to be an internal tool for us to make rigs from. But if you grab Pulse Spline modifier and you drop it as a child, I'm going to drop it before the electric, you're suddenly going to see that all of these are automatically animating. We're suddenly getting this burst, almost like this burst of particles coming out. So it's like we've already pre-designed what the paths will look like, and now we're only revealing parts of it at a time. So now we get this burst of them, and it's looping. Now we could say that this is a one shot. So, right when it starts, that's going to do a burst and then be done. And you can set start time, end time. We can randomize these. Pulse means it's going to be constantly happening. Continuous means that as soon as it's ending, it's actually coming back in again. We can reverse. So I'm going to change the direction. So all of them are going out. You actually say like a 50-50. So half are going in, half are going out. I'll say reverse for now. Actually, I might go to interconnect and reverse the sequence. I'll say reverse sequence. So now they're going in. Just so it's not inverting the pulse in my mind. So this is if we say every single spline should be doing the exact same thing at the exact same time. I could make the lines be longer. We could be seeing a smaller segment of them as they travel in. Lots of different effects just by putting this in essentially at default. Now, I'm going to go inside of this tab called weights, and you'll see that we're currently mapping from 0 to 100% on every segment of the spline. But there's a mode called subsequent. And that is essentially, that's when you see every spline in sequence to each other. So if I turn on subsequent, you're now going to see a completely different effect. Each spline is kind of like one little part of the equation. So even though that's the only thing that changed, we get a completely different look here. So I'm going to, let's slow the whole thing down. So how long is this going to take? I say 90 frames. So now it's going to take 3 times as long. And I'll say I want to see even less of it at any given point. And now you can see we're getting these little zaps going. Bzz, 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 bzz. These fun little electrical zaps happening. So now we could go and reactivate our electric spline modifier. And now we've got these little zaps of electricity that are constantly drifting in. Now, technically, it would be better for you to put the electric spline first and then this after, so the point count doesn't change. You see how when I do this order of points that the electricity looks super coherent? Do you see how it looks stable? But if I put the pulse first, do you see how the electricity is kind of like really, really twitchy? And it's because the point count is changing. The electric spline is expecting something constant. So think of what the order of operations is here. Here's what all the splines look like. And then we're saying, okay, now modify the electricity. And then we're only going to show parts of it. So that's what the end result is. But if we do the opposite order of operations, if I turn on pulse first, then suddenly we're changing like the point count and everything's moving around. So now the electric spline is doing the electrical effect, but it's constantly having to chase these lines around. So even though you do get something that looks cool and, maybe coherent enough, the lightning is now very randomized. So yeah, the order of these do matter, much like the order of almost everything in cinema matters. Given this configuration, I might not need that movement speed. And honestly, I like layering these things up. So I might grab the electric spline modifier and make a duplicate of it. Let's turn off the second one for a moment. This one, I'll say I want to do a purlin noise. And I'm going to say that the noise frequency, I'm going to increase this until maybe around there. And I'll do lots of displacement. And let's increase our speed back up to something like maybe like that. So now you can see I've got these giant wiggles going on the line. And then we make a second electric spline modifier. And now we've got this electricity on top of those big lines. So layering these things on top of each other is where so much of the power comes from. So now you just look at any given piece of electricity and you get this lovely drifting and electricity on top of it. So now we can activate our pulse spline modifier and now look at these zaps of electricity that we get. Now we're just revealing different parts at different times. And I don't know, it's just such a cool looking effect, layering these together, completely parametric. Look at this rig, complete control over the way that this is going to be behaving. And so it's like we've art directed it. In a lot of ways, it's like almost like an entire additional animation tool. You know how you can build particle systems and do proper simulations. But then, Maxon introduced, many years ago, the MoGraph system, all of the cloners and all of that stuff on top of it. And that became like this, it's almost like a particle system, but it's completely controllable. Like you say, here's a grid of particles, or a grid of clones, and now with a random effector, they're going to do something in particular. So here you can think of it sort of paralleling that, where it's like, okay, I've made a bunch of lines, and I just know where those are. And I'm going to say, okay, I want to take those lines and have them drift. And I want to take those lines and add electrical effect on top of it. And now I'm going to pass this pulse of animation through them and only reveal certain parts, but it's all essentially predetermined and every step of the way is art directable. So, if the client came back and said, no, like these large lines of electricity, like they're drifting too far, I could go back and adjust that. We could go back and grab just the electricity that we see in, the little bits of electricity here and control these independently. You see just a little bit on the line and then a whole bunch secondarily on it. Every aspect becomes art directable. So anyway, I think that, I love these types of effects and layering these up on top of each other. We could probably make it run even faster too. I probably don't need to resample that second one. So what's happening is the entire spline is getting resampled by this electric, and then this electric's resampling the previous electric. But if we just turn off resample, then we're just working from the existing points. And because the previous line was already heavily subdivided, that should be pretty dang subdivided for us. So, that'll actually make it go a little bit faster. And now we get these final lines. And what's really cool is these are what the final lines look like. So if we were to throw this into a sweep, it's not like there's a million points it needs to worry about. Like it's only going to worry about what it's actually seeing. So yeah, electrical effect, super duper cool. Layering those on top of each other, love it. And pulse spline works really, really nicely on top of it. Let's move on into another file here. And how do I want to show? Well, actually, I'll just pop open another interconnect. And let me look at what settings we still haven't talked about and see if there's any cool things to show off. Keep in mind, we've got all the different subdivision types in here. And that does mean you can do all sorts of really nice controls with that. I'm going to go back to a basic setup here. Like, let's just make the plane. And let's interconnect from one plane to another plane. Scoot that up. And then add in another plane. I'll scoot this off to the side. So you saw that we had all that. I think that this It's supposed to be off by default. You saw that all of those we have all the tangent controls, but we could just ignore the tangent controls. And I can go right in the subdivision and say, I would like to have the spline type be B-splines, the smoothest one. And now you can see that's just smoothly interpolating between these splines. So you can see I can actually control this curve super smoothly. And I get T for scale that down and get like this little pinched effect going. And actually, this is standard kind of Bezier spline stuff. I can make a second one, scoot that away, and now you see we actually get this perfectly pinched area, and it spreads back out again. And now this upper one can be larger, and you can see how quickly I'm making this shape. And how would you make this shape outside of this context? It would be incredibly difficult. So using the different spline types, super valid thing to be layering up on top of here as well. We saw explode segments, points, moon, indexes. Okay, we got to talk about that because it's really cool. Shuffle indexes. I mean, we shuffled either none or all, but you can also do the first object or last object. I mean, even I guess shuffling indexes here is not going to matter much. Break at junction just splits them apart. All the rest of it's relatively straightforward, but we have only begun to scratch the surface of the possibilities of even the things we talked about, all the different rigs we can build. And I bet you we're going to end up using this quite often during live streams. There is a lot more stuff that we can do with it. But there is one additional mode I want to talk about, and that is the bundle option. So I'm going to show you something very specific here. We're going to make a plane, and I'm going to drop its subdivisions here. I'm going to do something like that. So now you can see I've essentially got one polygon, and we want to deal with polygons. So let's make another interconnect. Pop that open, drop it in, duplicate, and move this up. And right now you can see that every point is connecting, but I'm going to say don't do every point. Instead, do the polygon center. So this just means I have this nice clean series of lines interconnecting directly from each other. Right away, I will grab both of these and invert their orientation because I want to get the normals going for a nice flow. Now, if I were to make a duplicate of this and pull this up in the air and maybe even make it wider, and we got to close it, closed. So now you can see that all of these are interconnecting. It makes perfect sense. But now let's grab this top one and let's increase the count. I'm going to say that there's going to be 20. So now you can see that we end up with this very specific pattern happening. I'll make another duplicate and we'll kind of walk through what it's doing by default. So you can see that we've got, let's grab both of those and set them to 10. So you see that both of those I said 10. Okay, now you can see that, polygon index 0 to 0 to 0 to 0. And then 1 to 1 to 1, 2 to 2, like all the way up to 10 to 10 to 10. But now if we grab these top ones and we say, actually, we're going to increase your count by 1, then suddenly it's like 1 to 1, 2 to 2, and then we eventually get 10 to 10. But now there's another one. There is an 11th one to connect to. So it's actually taking it from the last one and connecting. Essentially, it's repeating the indexes. So this must have been the first one, and now it becomes the last one to go. So as I increase this, you see each one stepping one further along and then connecting again. So as I keep on connecting these, they're going to sort of loop around. And once we say 20, we've got this, it looks like every other one, well, every one is splitting into 2. But keep in mind, it's not literally doing that. There are still 2 splines here to interconnect all the way. If I were to set this back over to B-spline, you're going to see that. You're going to see that they curve like that. Let's change it to cubic. I don't know which one's going to give it. I'm just trying to see which one shows. I guess they're all showing it pretty sharply. But yeah, there are, there's double lines going from here. You see 2 from that origin. Let's go back to auto, and you can see that there are 2 there. They're just overlapping. So that's what's happening there. But there's a completely different mode. Under surplus, we are repeating the indexes, but there's a different one, and it's bundle indexes. So this almost turns this into an entire second tool to do an almost unrelated thing. So I could say bundle indexes, and it looks completely different. What's happening now is it's saying like how many times, there's twice as many of these upper 2 as there are these lower ones. So that means take the first one and assign 2 points to it. So instead of them crisscrossing, you see we get the first 2, second 2, third 2, and it just travels all the way down the line. Now, let's make this look a little bit nicer by adding some tangents in. So we'll increase that a bit. And let's make something a little bit more specific. I will grab the bottom 2, and I will say it is just 1, a single polygon. And then the second 2, let's say that there are 2. And look at that. I've now got this bracket shape. So let's duplicate that again, and I'll scoot these up. And now I'll say that those are going to jump and double to 4. And now they split into another bracket. And let's duplicate those again. and move those up, and let's split them to 8. And you see, every time I do this, we're actually doubling the count as we go. And this is nice and clean the way I was doing it, but it doesn't have to be doesn't have to split that evenly. We could double this again. So instead of it being 8, I'll jump it to 16. And now you see every one of those splits into 4, because that's what one is divisible by into the others. Now I'm using nice clean numbers. You could, put in a slightly off number, and it's just going to have to do the math here where a bunch of them get 4, but one of them had to get 5. So keep the numbers clean, but it's not limited to being those super clean numbers. But now you can see I've got a parametric bracket going where all those are layered up. So there are a lot of possibilities for building things along these lines as well. Now I'm doing this in a really, really clean way, but we could keep on layering things up. I could have this bottom one split into 2. I thought that had 2. It does not increase that to 2. Yeah, so now we've split the bottom one into 2, and then it could split back into 1 again, and then you see that went up. I could pull it down. We can layer and layer these a lot, but there are so many possibilities. Now we're using that concept. Let me delete all those children from there, and let's make a disc shape instead and do the exact same concept. So now you see I've got this ring. So instead of it being a flat polygon along, now it's kind of twisted around. So let's drop that into the interconnect and drag this and move it up. And then you see we get those direct polygon to polygon connections. But if I duplicate it again, drag it up, and let's grab that disc shape and double it to 32, then suddenly you see that every line is splitting into 2. Right now, my indexes need to be reversed. And so I could duplicate that and pull this up and make, you see how we kind of split there. And I could make 2 more duplicates for there, pull those up. And this time, let's increase the radius of them. So you see, that shape, I was able to split it outward. And we could drop this down to 4. So now you can see all of these are splitting down into 4. And now look at that crazy shape we've got. And then maybe I split it back up to 16 again. So duplicate these, pull those up. But let's not do 16, or I'm not 32, but let's do 64. So now we're double those again. And now you see that all of them are doing this perfect pattern as we travel up. And again, I would have no idea how to build this outside of this context. If you were like, how would I model that? It's going to be so difficult to build this rig. But these all layer up so nicely on top of each other. Now, inside of the asset browser, there's a bunch of example files. There are a bunch. I'll save that one for last. But let's open up this one. So this one's actually using the concept we're looking at right now. So this is now making a whole bunch of different crazy bits of geometry using the technique I just showed for the most part. So right there, you saw how we had made the bracket. So you know how that one's made. And then there's a very similar bracket. Now this one, very similar, but this one's using some uneven numbers. And then I probably set the spline to Bezier as we were already playing around with it. And then here's doing that spiral thing, but we kind of built it upward, almost like a bird cage. But this is as if those rings were pushing outward. So yeah, super crazy effect there. Let me find that one. And if I were to turn off this interconnect, let's look at what the actual geometry looks like. And yeah, now you can see I've got the series of concentric rings that are getting interconnected to make those. So yeah, pretty cool there. Just a different, like these two are identical. It's just a different pattern and different numbers. Here's that same idea, but sort of 3-dimensional. So I was able to make this flower, which would make for a good hologram. Here's the circle, but they're open, so you only have to do a fraction of one. Here's similar ideas, but open, but twisting them around, sort of a spider web effect. And then all of these are, so here's like the bird cage. I was just essentially sort of building that in front of you, pretty cool pattern. Here's a double helix that was made from it. And then here's some kind of normal spirals. These are probably just some cloners. Yeah, here's a cloner. Yeah, so it's just let me show you. Turn off the interconnect and the sweep. And you see that this is just a series of 3-sided discs that are slowly spiraling up thanks to the cloner. And then we interconnect, and now we get this line that looks like a spiral traveling through it, and then we sweep it. So there's the exact same idea, but with more subdivisions. But then we take that same idea, and then we put a random effector or a step effector on there, and we start twisting the pieces individually. So I think we should be able to do that here. Let's grab this nice clean spiral, grab the cloner, and now instead of just right here, you see I can spiral one way or the other, makes sense. But we can start spiraling on a different axis, and you see it starts twisting into these crazy shapes. So that's the way a bunch of these other ones were made. Super crazy looking things. But again, this is just a cloner hierarchy, incredibly simple to make. This one I twisted really cleanly, and it kind of looks like musical notes kind of drifting through the air. So yeah, pretty cool there. Now, another use case for this is this one. This scene file would be a little hard for somebody to backtrack because I layered up a lot of different things. But like I said, a lot of the tools are being designed to work with each other. So now we've got these connections interconnecting randomly on the building. So we just get a big tangle of wires, and then I'm layering up additional wires on top of it. So yeah, this ends up being a fairly fancy rig. But let me just break it down to the super duper basics, which we can probably do right there. Probably. Can I? Those are those. And then source spline. Okay, yeah. So here's the initial condition. Essentially, I'm just cloning a couple of polygons right here. If I grab this, you can see, let's turn off the interconnect. So you can see I've got polygons there. I've just cloned some polygons onto the side of the building. We could do it on a polygon selection as well, but I want to control it. So there are some polygons cloned there, and I've got an exact number of those same polygons cloned onto the other side of the building over there. So then we just feed both of those in to be looking at the polygon center, and I say interconnect. So now we get random wires interconnecting between the two. And I probably got a lot of initial, actually, I'm not even initial shuffling because that didn't really matter. So this is almost like all default. I've got those lines traveling. Now, another tool inside of the asset browser is, let me go and let's make a sweep. So sweep, drop that in, and let's make a inside, drop that in as well. Shrink that down to like 2. Okay, so you can actually see those lines there. Now, another capsule that we've made, if you go down here, is catenary. So if we drag catenary in, and I'll say that after you've kind of generated that interconnect, do a catenary. And now we get these lines drooping parametrically. So we can say, okay, don't droop anywhere near as much as you are, but I want a lot of variation, high contrast variation. And now I've got hanging wires, a procedural rig. I could go into both these cloners and just say however many I want. It looks like I'm removing a lot of them. So I can just start increasing this line and make as many of those as I want, or as few of them as I want. Oh yeah, because it's limited to a selection, you have to have a ton of them, but it's limited to polygon selections on the building. That makes sense. So yeah, you end up with something like that, and then I could make a duplicate of it and subdivide it. So many of the tools were designed to work together, and interconnect is kind of the one that brings them all together. So now I'm just going to duplicate this. Not the best way to do it, because you can instance and layer things in a way that keep these all interrelated to each other. But if I make a duplicate of that, you can now see that. Let's turn off. Actually, yeah, well, even have the catenary happen. So okay, it has catenaried, and actually I will hide the first one. So now we're just seeing the active one. So this catenary is having them hang down. So now let's make a break spline modifier. So we've got this break spline modifier that we also made, and we'll put this afterward. And what this break spline modifier is going to do is break them into pieces. So you can see like there's a split there now. So it can make different splits. So right now I'm saying to do it based on length or based on a count. We can say a count of however many. So those are breaking apart. And we can add all sorts of variation on the distances. But now what if we duplicate the catenary a second time? The catenary should be working from, we have to change it from point to per segment. And now you can see every one of those lines got split at a certain point, and now we're drooping down from where that split was. So now you can see all of those are hanging down. And now let me bring back the original one. And now you can see that we have an original line that's going across, and then we have a secondary line that's drooping from the first one, essentially just based on the exact same rig. So this one, you probably just like shrink those wires down a little bit so those aren't quite as thick. And now we got those going. And then I think I interconnected some of the wires by randomly cloning points onto them, like via a matrix, and then doing a tracer to interconnect those. And then drooping from them. But anyway, you can see here is a procedural rig all interconnecting. This might not be geometrically stable, but the rig should be able to update well enough that I can grab this building, and you can see I can actually look at this. I can physically move the building, and I didn't know if it'd be stable, but the rig I built as it is stable. So I can actually keep those connected and drag them around, and we've just got all these crazy random hanging wires just automatically working for us. So very exciting. Let's see. I know one. This is actually one of the demo files inside the asset browser. So if you go into the asset browser, search for Rocket Lasso, you're going to see these hanging down wires. So you can get the end result. But yeah, now we got these wires interconnecting, making this. So now you can see that, like we were making bird cages. We were making electrical effects. Now we have hanging wires. This unlocks so many different cool, crazy possibilities. But for me, the most exciting version of this is the electrical effects that we can do. So let's go and open up the last scene file here. And this one I tried to keep it super low poly so I could have a bunch of them. But here's just a whole bunch of different layered up effects. You can see that they're running fast enough that I could have all of these in one scene. And we've got all these electrical effects overlaid on top of each other. That one's fairly complex. There's like 4 different rigs making this happen, like the ground one and the center beam and these secondary beams. Very simple electricity. Like this orb just doing that planetary thing. You see this interconnect. Some of these rigs, you saw me build similar things. Like this electrical effect here is very similar to us putting the orb around the text. This text is doing a similar thing, but it's being told that it can explode the segment. So every letter might connect to a different letter. Here's a very geometric looking one, which is kind of cool because depending on the noise type you feed into the electric spline modifier, you can get different patterns. And which pattern is this? It's one. This is a cell noise. So cell noise being that blocky looking one, but you use that noise to displace things, and suddenly you get this cool like techno look. And then here's just those lines wisping around. So essentially, that rig and this rig are all but identical, but this one just doesn't have electricity on it. And what's cool is you can actually make animated thumbnails for this. So I'm going to make that huge. And if we go down here, I can't make it any bigger for you, but if I go and I find it, if I mouse over it, you can see that there's the final render version of it as well. So, and it will like render and glow like that if you open up your scene file. I would really think you can make that bigger than it currently is, but there you go. Layered up. So some of the other ones got animated. I didn't do that. That's cool. I did do this one. So that is I'll say the basics of Interconnect, of all these amazing things you do. Honestly, it's the type of tool in my mind. It's not the simplest interface, but like there's not that much going on here. And it feels like such a core feature set for cinema that it just fits in so seamlessly in like a MoGraphy workflow that like it might it's in contention for being my favorite tool that we put together. And like I said, I think we're going to end up using it a lot. And I guess as we wrap this up, it's worth saying, it's like, here's all the different Rocket Lasso tools. There's one more coming out, but the last one that's coming out is not going to be anywhere near as like universally applicable. It's a super specialized thing. So you can, for most people, I would, look at this as like the complete suite of the Rocket Lasso tools that we got hired to put together. One day, I hope we get to continue with Maxon. So the more people use these tools, the more likely they are to ask us to make more of them. And very exciting. We'll probably keep doing more demos of some of these because a lot of these we didn't talk about back in the day in any sort of real detail. I mean, I love the branch spline modifier. We never really talked about Constellation, but it does some really cool things. And then we can do all these crazy things with the weave, the spline weave generator. Like there's so many cool, crazy things that we can do. Partition, we've talked a little bit about it, but not like a ton. So there are some cool possibilities. Anyway, I think that's going to wrap up me talking about it. But if people have follow-up questions here, then I'd love to tackle them. Before we move on to proper questions. And if anybody has any proper questions, get them into the chat. I know people have been chatting, so some of them have faded away, but I can always scroll back up again. Let's see. Any material gotchas for Interconnect? Sort of. Is there any material gotchas? The gotchas would be the similar, if you want to say gotchas, that sort of any MoGraph rig can have, in that each of these is a spline segment. If we did something like pulse and pulse is passing through it, then it could be that the segment counts are changing, that the one's the first segment count, the third is a different segment count. And maybe if Redshift was randomly assigning colors as the indexes change, maybe that color pops from one to the other. A lot of that just depends on the order that you build your rig, like where's the data coming from and then where is it going to. And then the only other thing to keep in mind is, let me find, are there more files here? Yes, they are. I was like, I swear there's another one. So with something like this, the electrical effects and whatnot, that sweeps can get, cinema sweeps. I'm me, I'm constantly complaining about the C4D sweep because I think it needs a major update. But if we put a sweep on this, it's entirely possible that you end up with, let me shrink these down. They end up with like those super spiky lines that go out to infinity. I think we're kind of seeing a tiny one here. You see like this spiky line that's shooting out. And essentially it's not a bug. It's just in cinema with a sweep. If a line gets really, really, really sharp, it's going to shoot out to infinity. In fact, I mean, this is a topic that we end up bumping into often enough. Let me just do a quick demo. I guess I'll just start with a simple rectangle, make it editable, feed that into a sweep, and it will feed in another rectangle, as simple as can be. So now we've got this shape. It's all good. But now if we were to grab these 2 points, I'm going to grab, whoa, why did that go so slow? Oh, well, it's not editable for one. I don't know why it's super lagged. So I'm going to grab this point. I'm going to grab this point. So the important thing is going to be, let's look at this corner up here. And I'm going to slowly scale these 2 points together. Now, right away, you see that it's like kind of like this 90-degree turn. So it looks really nice and sharp, where the thickness makes sense. It's a 45-degree angle where those 2 things would intersect. As I shrink these 2 points down, do you see that it's kind of like if you were to measure from this corner to that corner, it's actually quite long right now. Now, it makes sense. It's what the shape of that plus that intersecting would look like. It does make perfect sense. But if I keep on scaling down, you can see that it looks like it's getting longer again. Now, measure the point from there to there. That's actually quite a bit. It doesn't necessarily look wrong to our eye right now. But at a certain point, especially as we start getting down here, look at how this starts getting like infinitely long. As I keep on going, that is now this crazy long line that's overshooting. Now, keep in mind where I'll duplicate that and scale this up just to give you reference. That's where our rectangle, this is where our point actually ends, but look how far out that's shooting. Now, that is just a result of the stuff we were just talking about. That's where those 2 like rectangles are essentially intersecting and going off toward, nearer and nearer to infinity. And that's just a fact. So essentially, that is literally the same thing we're seeing right here, where we're getting this spike, where there's just a very pinched line, but due to the electricity. Now, having said that, if you want to consider that a gotcha, it's valid, but we could move into that electricity, and I do have some settings in here, like where is it? I know it's here. Oh, there, smooth iterations. So we can add layers of smoothing in there. So as soon as I add a single layer of smoothing, that's going to disappear. But you also see a lot of our electrical effects also seem to have disappeared because we've smoothed it out. If I get rid of that iteration of smoothing, you see everything's very, very spiky. If we add in the layer of smoothing, suddenly everything is smoothed itself out, which got rid of the hard edges. Now, there are other ways around that. So what I would, like the workflow I might do here is we're going to grab this interconnect and we're going to feed it into the Rocket Lasso plugin, not one of the capsules, totally unrelated things. So this is a plugin you buy. I could grab my smooth, and now you can see those lines are getting smooth, and it does a better job of smoothing them out. But I could do something like get rid of all the iterations, zoom on up, and then I don't want to lose like the electrical effect that I'm getting too much. So I could say, let's subdivide this. So I'll say, give me a subdivision. And now every single point has gotten a new subdivision in between. And now I could put a single iteration of smoothing in. So now you can see our overall electrical effects, like it's still drifting down and up. If we were to, get rid of every iteration and turn it back on again, you see it hasn't gotten rid of the electricity too much, but it's helped get rid of that spike a little bit. Now that's actually a fairly persistent looking spike. So you see if I do 2 iterations, I got rid of it. You see right here, this is probably this really tight cornery pinch where it's kind of zigging and zagging and pinching. But the more step inputs I put in here, and then the more iterations we use to counteract it, the more we're going to maintain the original electrical effect and be able to eliminate a sharp corner like that. Potentially a parametric bevel or a chamfer in the future could help for something like that. But as of right now, that doesn't exist. So that's another thing to keep in mind. And then, now these splines are heavily subdivided. But then again, keep in mind, I could now feed that into another Rocket Lasso plugin, or it's the same plugin, but a different aspect of it, and grab a reduction. And now you can see that it's gotten rid of all of those extra points because now it's saying, like, unless you're a very curvy line, eliminate it. And I could drop this down to 0.1. And you see that anywhere it's curvy, it's keeping it. Anywhere it's relatively straight, it gets rid of it. So I've reduced our point count back down again. And the sweep is the thing that takes a long time to calculate. So that's the one that counts. But you can see this reduction has, in this case, gotten rid of almost 55% of all of the points that made it up. If we put this back to a reduction or a deviation of 1, then now you see I've actually eliminated, we're only keeping 12% of the original points, but from a distance. If we were to zoom out to here, let me zoom out to here. And now let's say a tolerance of 0. Yeah, that's a tolerance of 0. And here's a tolerance of 1. And try and look at the difference. Really look at the line and try and see a difference. As soon as I click, barely a difference, but we've gotten rid of almost 90% of the points. So that's I love the reduction tool that we built. I think we came up with a really clever algorithm to deal with that. Yeah, let me read through, see if there's more questions about it. Let's see. Badger, appreciate it. Um, do, do, do. The ATD, we were, it was a deal when we talked with Maxon about the plan, was that we were not going to make any tools that invalidated Rocket Lasso tools. Like we spent a long time building those Rocket Lasso tools, so that would have to be a different type of deal with Maxon if they actually wanted our plugins integrated. Um, let's see. Yep, showing it off. Yep, Joe, I answered that we can add electricity. Mm, 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 mm. Bihavana, that those tools have nothing to do with me. Let's see. Oh, that's a proper question. Oh, yeah, Brand Spline. I mean, Brand Spline would play with these, but depending on how the way you're animating and whatnot, it wouldn't necessarily help too much. But they could work together. Yep. That's included in the file. Proper question. Do those spline offshoots happen if you don't put it in a sweep but use Redshift? Yeah, Redshift does a way better job of it because Redshift is doing something very different. So this is doing an algorithm where essentially it's taking, if I was sweeping a rectangle and it's kind of like a rectangle, you can imagine a series of these rectangles at every single point and it's interconnecting between those and scaling the rectangle appropriately so that it looks like a continuous thickness. But is there a way to show this? But what Redshift does is completely different. Redshift is almost like creating a series of clones. Here, I'll have to do it in a very clunky, literal way. But here's what Redshift does. Instead of sweeping it, Redshift is doing the equivalent. And let me show you. If we right click and we say render tags, Redshift, and then we say here's a curve, you can see it says something like hair strand. And I guess maybe hair strand is doing something semi-similar, but I'm pretty sure it doesn't explode. But what I want to talk about is if you're using cylinders or especially if you're using capsules. So if we were to make a capsule here, because this is quite literally what it's doing, it's just doing it kind of at render time, is it's kind of like making this capsule shape. And let's say we were to grab that, let's aim it on Z, put that into a cloner, and I'm going to turn it to multi-instance, clone onto an object, and the object will be this interconnect. So we're going to set this to maybe step size, and we're going to keep on dropping the step. We got to be careful not to go too far. But if we were to make this to be a very tiny little capsule shape, and we keep on decreasing the count here, so I'm going to make it really small. Do you see how I end up with this whole series of capsules interconnecting between each other and essentially tracing the line? So this would be as if, and I made the capsule a little bit long. So let's drop that down to something like 2, well, maybe 3. So you see we get that little capsule, and I just keep on cloning this to smaller and smaller sizes. So these all start like overlapping each other and then tracing everything out. So we don't get those like super exploding lines overshooting each other because this is really just a series of teeny little clone capsules. And the smaller, I could keep on making smaller increments here, and the capsule could keep on being smaller and smaller. And eventually you're going to get like essentially a perfect copy along the line. And that is kind of what Redshift is doing. So you see, this is like an alternative way of sweeping something, but those corners can't explode because it's just kind of a clone capsule right there. Theirs would be a little bit smarter than this raw clone that I'm throwing on there, but that's the principle of what Redshift would do. And then I'm not so sure about when it just says hair mode, but it doesn't create the spike, so I'm not quite sure what that one does. But yeah, excellent question. Let's see. Question: could a JSON, CSV, or any of these files, or any kind of data file, drive the interconnect capsule to drive the data viz? That's a fine question. Cinema just doesn't import that type of file very often, and we definitely do not read it directly in. We cannot and do not. I think it's more like we do not and cannot read those files directly in context in Nodeland. Like there is no node that says read a CSV file. Um, maybe there, I don't think there is. So yeah, so we can't do that. So you would need that data to get into Cinema some other way, and then drive the incoming objects. Um, they unfortunately, and then so yeah, I wish there was a there is a CSV node. We used it. I think when I was building the graph spline generator, or when I made the graph spline, which is another one that we have here, this graph spline, which is really cool. I tried to use it, and it was honestly, it just wasn't quite working yet. It wasn't fully developed, and it wasn't fully developed in a way that let me open that up. It wasn't fully developed in a way that it actually worked. So I ended up having to do this workaround where like there's this data tab, and then you can type in manual, and you have to like append this information manually, where I can keep on adding in additional data points that you can use to like drive these different segments. So that's a very frustrating and manual way to do it, because the CSVs just did not work and they were going to get redesigned. I don't know if they ever got redesigned. Technically, I think Espresso can also read them in somehow. So it's more like you would need maybe you could take the CSV data in Espresso and then use that to drive like the heights of the clones or the individual polygon segments, and then Interconnect could be interconnecting them for you. But yeah, as far as that type of data like input, like I just don't have any. I've never had to do that type of work. I don't have good intuitions for it, and Cinema is not very cooperative when it comes to importing that type of information. It would be really cool if it was a thing. Somebody else just asked if it works with a matrix object. Unfortunately, we could not read matrix objects directly using that same workflow, but the workaround isn't too difficult. Again, I wish that it was easier, but essentially, instead of doing a matrix, you have to do a cloner, and what you do is you clone a single polygon. So you just say single polygon, drop this down, and it can be infinitely tiny. I'd say like make it really tiny. I'll also say 11 so we can actually see it. But yeah, I can drop that into the cloner. We can make a whole bunch of these, do whatever we want. So in fact, I'll just say make a random vector. We'll give it some noise indexed. We already know it's really fast. We'll increase this up to a bigger number. So now you can see that we've got those doing their thing, and they're all drifting around. It's doing MoGraphy things. We couldn't see a matrix, but you can do it with a single clone or a single point. And then I put that into connect. And then we can make an interconnect. And then we'll feed that in. And then I could make 2 copies of it, or I'll just say explode segments in this case, and then you see they're interconnecting like that. So each one's interconnecting with each other. And then we could shuffle the initial indexes. And let's say that they break at the junction. And let's shuffle them. It doesn't. Oh, okay. There. I was like, it almost doesn't look like they're updating, but it is updating. Oh, and then we change this to polygons. So now we've got all these interconnected, like one segment to the next. And yeah. Let me think. Repeat indexes, shuffle indexes. I thought there would be a good combination that we could super duper overload it. Maybe not in explode mode. But yeah. So no matrix, but yes cloner. Okay. Yeah, somebody's saying X Particles has a data importer. Yeah, I would love for Maxon to get a little bit more friendly suite of tools, like a data importer for a cloner and whatnot. That would be cool. Yeah, I think that wraps us up. If anybody has any follow up questions to any of this, then feel free to plop them in the chat. I'd love to talk about them some more, and we will. I'm sure we will be using them often, because ever since we built and conceived of this tool, And I've been doing live streams all the time. Like, oh, I wish I had Interconnect. It would solve the problem perfectly. But I do think it's going to unlock a bunch of really cool new motion graphicsy effects that you could not do before. So it is definitely one to just play around with. And honestly, if anybody comes up with anything cool, please share it with me. I'd love to see them. But for now, we just spent a whole hour, a whole half of it, just talking about a new tool. But hey, it's a tool that everybody that's in the newest version of Cinema should just have for free. So definitely a fun thing to talk about. So I'm going to scroll up and look at some of the questions I got asked before. We got sucked into that topic. Let's see. The ballistics gel question is a non-trivial thing. I'm not sure I want to bang my head against soft bodies right now. Maybe not, but I'm going to jump to Mr. Fresh's question, who has not asked a question in a long time, asking if we can achieve similar results with particles. Let me see what it is. Okay, it's stock. I'll switch the screen in a moment. It is Pinterest. And okay, it's just a still. So yeah, we can explore this in such a way that I don't think we need specific questions. Yeah, it's Adobe stock stuff. So let's take a look at the correct screen. Okay, so this is the idea. It's just it looks like these particles drifting away. We've got this line, and then they drift away into space. And can we make that with particles? Was the question. Okay, let me think. How might I want to do this? I mean, technically, you do some of that with Interconnect, but I don't think that would actually be the way I'd go about doing that. Oh, and by the way, I don't know. Actually, I don't know. I'm trying to think. Does Interconnect work with particles? I guess we gotta find out real quick. So I'll just make a basic emitter, and we'll make some turbulence, and then we'll let that start spitting out particles. Initialize. Initialize. Oop. Okay, so makes particles, and now if we made an interconnect, and then we say to view the particle group and explode segments, maybe. Maybe we have to make multiple ones, but maybe we need to tell it to return. How do we do that? I haven't done that in a little bit. There's how do we make them real? Handles during no. Cache mode. Because they live on the don't they live on the GPU, and they need to become real by turning on something? Did they change the way that worked? It's also possible that it just doesn't see them, and we'd have to actually clone particles onto them or clone polygons onto them to do it. So you could still do it as a workaround. I suppose I'll make a duplicate and then link a second group just to see. Oh, okay. So, okay, we can't explode the segments, but we can't interconnect between two. Well, no, with no changes, we can interconnect between two different emitters. We just can't interconnect between, we can't explode segments of a single point, which is interesting to note. But yeah, anyway, that's kind of cool. Okay, so those lines drifting away. I can think of a lot of ways I might be tempted to do it. Like the first way that jumps to mind, I mean, we could use Interconnect for it, some sort of unmotivatedly, but let's do it because we got it. We can make a plane. I know you said with particles, but let's explore our possibilities here. So let's change my layouts. Let's change this to be I mean, we could do this with a spline and a cloner, but let's have some fun here. So I'm going to put the plane. Let's make a duplicate of the plane. Scoot it. Actually drop it aside, scoot it along. So we got a big old length of a bunch of splines. Really easy for me to change the count of them. And Then we can go to subdivide and interpret them, say every 5 units. Maybe we'll say every 10. And yeah, so that just gives us a series of lines that we're able to easily change, and I could make more copies and drift them and do whatever I want, or scale them and make more of them. So lots of different layouts we could do there. So what if we just made them a rope simulation? Oh, and let me make sure I turn off closed. So right click and say rope. Let's go to Control D, simulation, nope, scene, gravity, turn off gravity, so that should be fine. I'll hit play just on these just to make sure that, yeah, so nothing happens. That's what we want. Nothing happening. 999 frames. Okay, now let's make a turbulence. Simulate forces, turbulence. Give it some scale, relatively large. 25 might be too strong, but let's see. Okay, cool. I mean, pretty much exactly what I want. You see them all drifting. That was pretty much exactly what I want. Might scale this up to like 150. And let's make it a little stronger, like 35. Okay, so now let's limit the turbulence to a linear. Change that to aim back on Z. I always mix up what's forward and backwards here. So let's do this. And yep, I did it backwards. Z minus. So now you can see that there's going to be a fall off of this turbulence, and the back part of these lines should be getting full turbulence, and these early ones are not. So I could keep on just drifting this forward, and you can see that perfectly. We could have those lines start drifting and transitioning in and doing whatever we want, as far as all the behaviors. Very clean, very art directable. So yeah, I mean, generally speaking, what you can, like, if I can get away with not doing it with particles, I will do it. And then after that, now here we're getting away from particles by using simulation. So if I can do it without simulation, that's actually my preference, is doing something that's completely like not frame dependent. Like, obviously this is frame dependent, but yeah, I mean, as far as I'm concerned, it's like, okay, that's nailing the basics of what the effect are. And what's cool is, like, with Interconnect here, super easy for us to grab these planes and art direct this, where we could say that there's supposed to be more segments along, but fewer segments vertically, or we could drop this all the way down. In fact, yeah, we'll drop it down and stretch it wider, make it skinnier, and I can even say interconnect, not points, but polygons. So we just get this one stripe of lines. Exact same effect will be happening here. Let's stretch that out further, do something like that. So now you can see I've got this stripe going. So very easy to art direct that series of lines. But like I said, we could also have gotten away by putting a straight line spline, subdividing it, put in a cloner, put that into a connect, and we could have been doing this exact same thing. But yeah, art directing that. And then even if I was going to do what that final visual looked like with like the really nice lines and them fading out and all that, all that can be done here with like materials and the effects as I'm feeding them through. But we could just clone particles on here as well, where particles could be getting spawned from the end result of these lines drifting. Now, the alternative, I mean, I will save this scene file. So we'll go to episode 15. And of course, everyone, you will get access to the scene files. I didn't bother saving any of the scene files of the Interconnect, because like most of those effects are in the asset browser for you. Drifting lines. But anyway, you get access to the scene files later today if you're supporting at the engineer tier on Patreon, which is always appreciated. So this was the very kind of clean version of the rig. If you were to do such a thing with particles, it would be, I'm trying to think of a way I could make it not be, how do I say this? Making a single one of these lines with particles is not terribly difficult, but making a whole collection of the lines is significantly more difficult. So let me explain. We can probably just pop open a new scene file, and I'll make a particle layout emitter. We'll just make this a point emitter. So it's a single point in space. It's going to be firing particles forward. I'm going to say constantly emit one particle per frame. And if I play, then we should have this continuous stream of particles coming out. I'll give myself way more frames, and let us increase the size and the viewport. So now you can see we got this continuous stream of particles. What's interesting is I just told it to emit one particle per frame. There must be speed variation. Is there still speed variation? No, there's not speed variation. Why is that? It's a constant rate of 1 per frame, continuous. Yeah, I'm not sure why those are an uneven layout. Shouldn't that be a perfect uniform string of particles? I would think it would be. Um, but anyway, we've got this continuous string of particles coming out. So what we can do is just interconnect them, not with interconnect, but with a simple tracer. So I'll just click on tracer. Actually, I need the group selected. Click on tracer, change tracer to, I think, connect all elements, maybe. Yeah, now you see I've got this line. And now I could do very similar things. One would be, let's make that same turbulence here. And yeah, nearly identical. Extra strength there. So now as soon as the particles are born, they're going to start, I guess there's quite a, okay, that's a lot of turbulence. It's affecting the particles a lot more than it was the rope. So now you can see I can lower this. And now you see we get this line that is interconnecting between all of those. And you still get, it's a similar effect where it's kind of doing this wispy smoke. And generally speaking, it's drifting off in that direction. We could make a wind to tell it keep going in that direction. But actually, this is doing a good example of showing the limitation I was going to mention, which is as they get further apart, then you see they start breaking down and we start getting these really sharp edges on it, which depending on how far out of your scene they're going and how much friction you add in, and there's other ways to maintain the relationship better, it's going to lose its resolution. So let's hide our particles, and you see it starts out nice and smooth and it's going to get more chunky. This is another wonderful use case for grabbing the Rocket Lasso utility spline and feeding into a smooth, where I could resample the entire spline with a step, which probably even here is too much. And then we can have as many smoothing steps in here as we like. So you can see even those hard edged ones, we can really round those out. And now, even as they drift out into space, you see we're always getting these nice clean curves going along. So, that works nicely. And we could decrease our turbulence even more and just let those drift a little bit more slowly. But like I said, this is a lot harder to build the rig because we're just emitting all these particles from one point. So it's almost like I'd have to copy this entire rig to make multiple ones of it. And then you have to make changes to all of those layered up, because if we were to grab this emitter and say, actually, it's not a point, it's going to be, say, from a cube, then we're emitting points all over the place. And you're going to see that they're all going to interconnect in this really messy way. So it's not the same thing at all anymore. So yeah, so that rig just becomes significantly more complicated. Feels like it just froze up. Maybe. But let me go and check the chat and see if you did that kind of cover the part of the question that you were interested in, or was it a different aspect of that? Because it's like, to me, that was the interesting aspect of it. Let me kill this off. Sorry, cinema. And let's pop it back open again. Let's see, who asked the question? Oh yeah, it's Mr. Freeze. Are you still around, Mr. Freeze? I'm sorry, not Mr. Freeze, Mr. Fresh. Been watching too much Batman, the animated series. Yeah, you said similar result, but that's kind of abstract. So, and you know me, I always tackle what I consider to be the interesting aspect of the question, and not, we're not necessarily trying to create the final. Every once in a while, we try and create the final and make something look really pretty. But generally speaking, I'm interested in the technical part. All the cool artists out there can go and make it look beautiful. You're running on the reveal part, how to spawn particles in this pattern. I'm not I can't click on the photo any more than what you had seen. It doesn't really zoom up for me. Or I'd have to be logged in to Pinterest. And Pinterest annoys me now with all the AI. Let's see. I mean, if we want further, how would I want to do it? I did just save it, so we didn't really lose anything from that. So if this was our rig, and we could do stuff with particles, but like I said, we could clone particles onto here, which is what I'm sort of inclined to do. And I would be curious to see how well the cloner can handle a capsule getting animated through a rope sim. So let's see what that does. So let us make a spline emitter. And we've got the interconnect got fed in properly. I don't use a spline emitter ever, so we are emitting points along in a random interval with a spline thickness of 0, continuously emitting 100 of them. Okay, that's fine. So if we hit play, let's see what we get. It's got to initialize all over again because we crashed. Okay, quite slow suddenly. It's really hard for me to tell how subdivided this is. I'm actually going to throw it back into utility splines again. I'll put it into a smooth, but just so I can double click. And yeah, you can see this is actually very, very subdivided. So we probably don't need to subdivide it nearly as much. So I can grab this interconnect and say, let's double the max length. So there's fewer points. I can yank it back out of smooth. Now let's run it again. Okay, well, now my computer is just like, okay, let's go turbo fast now. Okay, so that's emitting the speed. Yeah, there's still lots of speed. So I'm going to say no speed whatsoever. And the turbulence will be affecting those particles. So now, but then they're going to be born from the line. And I do want to see if they're born from the deformed position of the spline or only the original one. Very important. Yeah, okay, it is from the deformed position. I just saw one. Now, what do we want to do? Why don't we have this spawn way more particles? Let's do at least 10 times as many. We're going to limit the life to be quite short. Let's say like 20 frames worth. And let's do some crazy colors. Let's do some random colors from a gradient. And I'll grab one of my favorite neon ones that I've made. We'll grab that one. And actually, yeah, it's random, not noise-based, and I do want pure random, so that should actually map all of them properly. Let us show these a little bit larger on the screen. And then we can start mapping some of the data. So yeah, now we got a bunch of them flying. If I deselect, you actually see them. So they are being created kind of along the line, and they're free to drift based on the turbulence, which is fine. I don't know if there's an inherent velocity, which would be kind of cool. Density distribution, output, turbulence, speed map, direction, radial. Add emitter velocity. That's what I want, but I don't know if it will work. Very hard to tell. Like they might be getting the speed from it, and they might not be. Kind of doesn't super feel like it. Okay, let's modify this a bunch more. I'm going to say 10 times as many particles again. 10 times. Okay, now we're getting somewhere. So now we got a ton of particles coming out, and they're all drifting around. Now I'm going to make the splines themselves be like an effector on top of it. But for now, a couple things I would like to do. I would like to remap some data. So let's grab a data mapper, and I'm going to map the age as a percentage, and we're going to map it to the radius of the particle. So when they're 0%, they're 0, and then they are very small. Let's say 5 in the beginning. And let's see, did that data mapper itself just make them crazy slow, or is that just this wacky machine? Sure. Oh yeah, and now I have to go to the data map, or I have to go to this and say draw the radius, and then shrink that down to pretty much nothing. Okay, now we see this little circle representing them. So now they should, as they get older, they should be shrinking. Did I do it backwards? 0, 0. Oh, that's when the age is 100. Yeah, I did do it backwards. So 5 to 0. Okay, now they're born at full size, and they're going to fade out as they travel along, which I think is just a nicer looking effect. And then let's save it. Let's do drifting lines and particles. Okay, and then it's hiccuping. Give it a second. Are we getting a second crash already? What's going on here? Look at this icon. It looks so. Why does the icon look so pixelated? Look at the icon on the mouse. I don't even know what symbol that is. I think it died. Hopefully it successfully saved first. Well, why did it die? That's very confusing. Womp. Womp. Relaunch. Hey, it reopened on the first click. I didn't have to double click it. Open drift lines, but it crashed, so we gotta grab the fresher one. Open. I mean, it's there. It opened. Okay, go figure. I mean, we lost nothing because I crashed immediately after we saved. I mean, and these are just generating lines. I don't think it would be a combination of the interconnect because like the interconnect is not refreshing, so I don't think it's like a capsule thing. It's got to do the initialize again because we just opened, so it's got to send it to the GPU. Boink, 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 boink. Okay, cool. It's decided to run super duper slow, but you know that's this machine, not cinema. Okay, so I wanted to grab another effect. Let's go to particle layout, and they did add in some of those wonderful, wonderful spline. Where's the spline one hidden? Did I never add the spline to my layout? It's possible. Modifier, spline follow. Yeah, it's under. I don't think I ever added that to my interface. Oh, that's my mistake. Yeah, we can say follow spline, and the target spline will be the interconnect, and then we get all sorts of controls. I have not used this since I made my what's new video about it, but a guide, a rail, the mix, that's, you know, potentially trying to travel along. The main thing I'm interested in is the strength attract, but we'll just have to see what that looks like when it gets there. So I just saved it again. And okay, now you see all the particles are trying to travel along it, but they should in theory be trying to, I'm going to keep on increasing this attract. And is there a distance? Effect radius is actually quite large. So now you see I put a lot of attract strength on there, and you see these are constantly trying to get back to the closest spline that they were from. So I think that might end up being a really nice effect. Now we can actually hide our original spline, and now we're just seeing the particles. So yeah, now we just get the result of those particles. Let's grab our follow spline and reverse the direction. There's probably a reverse direction here, maybe, but I'm going to grab the interconnect and say reverse the sequence. So the spline now goes the other direction. So yeah, now you see they do travel the other way. And yeah, the spline follow, we got all sorts of settings we can do here. So we got the attract strength. I might make that less where I want them to be able to drift around a little bit. And it's got quite a large radius. And then that's the attract, but here's the follow strength. So I'm going to make that like 3 times stronger. So now you see they want to travel along the spline a lot more. And like already that looks pretty cool. Yeah, I'm digging that. I think it might be nice if they're making clusters of color rather than all these random ones. Although maybe based on the very nature of the way I'm emitting on this line, this won't work. But if we go to our color and I do it as a noise output, and then we double our knots and double our knots, and then we make the scale huge. Bonk. And then we restart. Okay, close. Let's go more. Let's do 8888. So now we get, now I get these clusters of color. But as I travel along the spline, new ones will generate. But yeah, in general, it's kind of giving us some clustery colors. We could do another kind of color blend on there if we were so inclined. But that's looking pretty cool. I like the way that they're drifting. And yeah, these it almost looks like little bits of data kind of traveling along. So yeah, already it's kind of a cool looking rig where we're using the spline as the basis of creating these drifting lines and then creating these particles from it. And even that goes to, we could add multiple effects here. Right now, this particle group is going to only use things that are inside of it. So I could do that. And I think that will still affect this, but the thought is, what if we make a second? Let's rewind. Save, and I'll make a duplicate of that entire rig. But this one, I will temporarily not have it follow the spline. And then these, how would I do it? Essentially, I want some to be on the line, and then these, I'll just say, are a lot smaller. So these will be tiny, but these will live a lot longer. So the expectation will be, I don't know, 60 frames. So now we got tinier particles also emitting, and you see those are free to drift away. So now you get the main, this is pretty much exactly what I was hoping for. We have these distinct main tentacles of particles getting implied, but then we have these secondary lines taking on the exact same types of colors and just drifting along. Now we could have had these like spawning like children, and that would work. That would be cool. But not strictly necessary. And I like this drifting. Now we could reactivate follow spline here, and now these little ones will try and follow, and we could give it different properties. Like I could say, don't worry about being attracted at all. So now you see they're drifting along the line in the same way, but they're free to drift away from it. They're not getting reattracted. So yeah, that's some really nice movement. We could say, yes, you're attracted to the line, but less, and yes, you're following, but less. So now, generally speaking, they're going to kind of want to follow the line, but they're a lot more free to drift away. That also looks cool. It's almost like there's no combination here that's going to look bad. Which is neat. I may grab both of them and just make this even bigger. So I'll do 2, 2, 2, 2, which is more than double, just to get some more coherence on the color. Because as they separate out, I think we'll just see those colors a little more consistently. And yeah, so they're shrinking down to nothing. And yeah, distinct tendrils, we got those going. I'll grab the follow spline. Let's make it even less. I'll say like 0.25, just to get it kind of implied to follow along the line, but still traveling. And yeah, I mean, we could keep on going and going here. Maybe we can just get a nice still going for ourselves here. I think that these will render out of the gate, but let's make I'm going to grab both particle groups, right click and add a render redshift, and then it's on particles by default. They're disabled, but I'm going to say that they just render out of the gate, don't they? Like if I turn on redshift, render, maybe they don't. Point instances. Okay. Point instances. Now we see them. Very nice. And then I think we'll make a material for them. Double boop. Inside of said material. Now they're black and white. Seemingly based on their age. That's interesting. Or maybe, actually, I'm not sure of why they're brighter and dimmer. But let's make a user data, right? I think the color user data has a particle preset. Yep, standard particle color. And then we'll have that. Let's not have color, but we will have an emission of 15. Very, very, very bright. Output the emission color. We'll link that to our color. Now they're super duper bright, which is pretty much exactly what I want. We don't, right now they're reflecting. Technically, that's just render time we don't need. And then we go into our render settings. We add a redshift post effect. And some bloom. Find a reasonable threshold here. And then I'll turn that off for a moment, and let's grab some streaks. Enable that and do that. So yeah, kind of completely different effect here. Have it have like crazy long tails, but a very like weak effect, or we can have the tails be relatively short, but be relatively bright. Softness, number, angle, like all these, can change the overall look, get the overall intensity. So yeah, lots of different dials to do here. So, kind of finding a happy medium there. And then also turning the bloom back on again. So, kind of both of them all mystical looking on top of each other. And now let's go and frame up. Yeah, they're not drifting. There's not like a tail that's like super duper far or close, but I kind of like to get some of these like way up in our camera. Yeah, well, I wanted to get some some bokeh effects going. So I'm just trying to find an angle that'll give us something akin to what I'm going for. Yeah, we'll do something like that. And let's make a camera, link to it, and let me think. I don't reactivate these things super often. Yeah, we got color correct, which maybe we'll end up doing, but I'm mostly interested in optical bokeh effects with a very, very low aperture. Yeah, so now we get the crazy bokeh effects going. And now this is all about where our target distance is. So we could make a null, go to a top view, and just kind of target somewhere like there. Focus, drop that in. Yeah, so now these are all super duper getting out of focus. The more in our face any given particle is, the more kind of blown out it's going to be. I'm intentionally over exaggerating the effect, but you can see how these are doing this really nice job of blowing out. This is all sort of defaults turned on, but yeah, within the actual bokeh effects here, you have all sorts of very specific controls that we can add in here. And I'm not an expert in like what real world cameras are doing, but different blades for what the actual camera aperture would look like and whatnot. We can spin them separately. But anyway, I think that's looking kind of cool there. Yeah, now we can try some different angles, just see. Come on. Yeah, and some motion blur might be good here. My camera. Why is it not letting me? It's doing like a weird thing where I look at it, so I try and move, it's moving very, very little. I don't think it's the render doing it. There's just kind of nothing in the perspective to allow me to move. Okay, that's. Oh my god, it's driving me crazy. There. I need like a physical object to be able to like not latch onto there. Go figure. All right, let's do something kind of like that. Redshift, render view. Now, I mean, there's a bazillion different ways to interpret the stuff that we were seeing. This is just, I put these together. Once you start like layering particles on top of each other, you can just keep on going more and more and more. Like it really is quite endless. We could have the lines themselves get rendered here. That might look kind of cool. Why don't we do that? Say that those are on now. Drop those there. Tell that to render as a curve. Let's try a hair strand. And I just want to really see them, so I'm going to make it huge. See, this interconnect is not going to take on the color. It's not going to take on the color of the particles because there's no system that would do that. So we'll just have them glow white. So I'll make a duplicate of the material. And I guess we don't need that. We'll just use the white. And now we can drop the thickness down. I think a little is going to go a long way here. Yeah, so now we got that initial line doing it. And it's actually crossfading like into them pretty well. Are there any, we can start a little render here if we are so inclined, but is there any questions, anything that we want to follow up on this thing more specifically? I think I do want extra particles for the initial, so let's triple the count of those. Let's double the count of the other ones too. Actually, I did triple that one. Oh well, we'll triple both. Okay, let's turn that off. Render settings, output, that's fine. All frames, that's fine. Don't save. Boop, 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 and boop. And then I'll see if there's any questions. We'll continue modifying it. NAS driver saying is interconnect available in 25.3.1 should be. I'm in 0.3, and anything I guess I need to update to the newest one. But yeah, anything that or newer should always work. TJ, welcome. Is there a way to keep turbulence but lock the ends of the spline to a plane? But lock the ends of the spline to a plane and keep them from folding back into themselves. Oh, I see. Yeah, okay, interesting question. You with a rope, you can just grab the end points and say, don't move. Now, you're saying that you would want the points to be able to move, but not move backward. They want to be stuck in kind of the plane that they are. So we were using interconnect, and in theory, it's like if we took those points and we just kind of deformed them to be moving around, and we ran the rope simulation on top of it, as long as we weren't generating, if we weren't creating nor destroying points, that would work. Um, Generally speaking, I would do something like make a wind and just let a wind gently blow on them to keep them in that general direction. Um, because yeah, right now they are free to kind of twist around and like fully curve the wrong way. We just haven't run the animation far enough to let them get that far. Um, but yeah, I think yeah you could definitely do it that way. Mm, each rope rig could be independent. I was trying to think of a way of doing it as a group, and I think maybe Interconnect could do that. We could maybe make a separate file and see if it would survive that. Interconnect doesn't have a distinct subdivide to a particular number of points. So we might actually have to use a Rocket Lasso tool to be able to have them have a constant number of points. Specific modes that we made inside of all of the utility splines do enable that type of thing to happen. Everything's a little blown out here. I tend to make everything be a little too glowy and a little too blowout, but we're in a live stream. I'm not an art director. I totally should have lowered the render settings, but we're just gonna let it chug for a little while. Let's see. Is there a way to separate particles into groups and add random numbers, disks, planes, etc.? I mean, yes. I mean, you can add, and you can make any condition, and there's a ton of conditions because we've got regular conditions, field conditions, time conditions, and within this condition, there is every possible thing that you could want as far as like age, alignment, speed, color, distance, the group it's currently in, the total lifetime position, and you can set the custom. And now this could be any property that we're making on any of the particle systems. So it truly is limitless. And then based on that, you can use the switch group here. So that's like an action. So you could say, you could do different behaviors like, oh, if this spline is doing this behavior, whatever that behavior is, switch to this group. And now that group does something special. And that different group could be that a certain type of thing is getting cloned onto it. Or, you can just like here, I made two different emitters, one that's supposed to stick to the line and the other is supposed to drift away from the line. You could always just make multiple emitters that are doing it. So, definitely multiple ways of skinning that cat. This hasn't gone very far, but let's take a little peek. Whee! Yeah, already the way that drifts up is kind of nice. I definitely would put a gentle wind that would affect only the splines drifting off that way. Because already you see that one curves up. Now, I do like the way they all sort of like start interconnecting on us, but yeah. And right now, a lot of what we did here was like we'd made multiple lines in one go, but potentially this all could have been off of one line, and then we just copy the rig multiple times, and we get different behaviors depending on that. Let's see. Paul, that's a completely different question. Are there any follow-ups to this rig that we've been tinkering around on? Oh yeah, and Mr. Fresh, I was saying the different conditions, but keep in mind you also have field conditions. So it could be like, oh, certain things have entered certain areas, so they're going to, like they've crossed into a threshold of noise, which means they're one type of thing or a different type of thing. Really is quite endless. I think the amount of glow I put on here is starting to annoy me, but what are you gonna do? Wee. Let's see. We have another thanks. Yeah, Paul has a question about, we got 15 minutes left. That's not a lot of time to do a water sim. Rain on a window being the question. Rain on a window. Yeah, there's potentially quite a few different layers to that. That's why I was kind of hoping there'd be little follow-up questions to this existing kind of particle rig, because we can tweak this for a little while without jumping into an entirely different question that we might not have time for. Especially because I would want to experiment with the liquids, and that probably means we'd be having to A/B test a bunch of times. Well, Paul, actually hit me with a question next week. If you're around next week, hit me with it. I'll be keeping an eye out for it because it would be fun to do. EJ came out with a really nice tutorial for getting bubbles inside of liquid, which was really cool. He did it just with cloning spheres onto it, but you could also have it be its own liquid, a different liquid, so that bubbles could merge into each other as well. And what I would be interested in would be liquids that have bubbles inside them, but the bubbles could escape and essentially pop out of the liquid. So essentially, you could let them die if they escape the surface. And I was trying to think of ways I would do that. I wonder, can you feed multiple liquids into the same rig? It's entirely. I don't know if you can hear the laptop's fans are revving up, getting this render going. The poor thing. It's keeping my hands warm at least. Yeah, as they drift apart, it's looking a little bit better, but I definitely calm all the brightnesses down a little bit here. But I do, yeah, because I like the subtlety, but the subtlety of all these random rainbow colors here, rather than them all just blending together with a big blur. But anyway, I kind of have a question of my own that I want to answer. So I'm gonna put my question to the front of the line. I don't know if we'll be able to do this, but here's a thought: if we make two different liquids, and if one has more, I don't know, not viscosity, but maybe like whatever the gravity parameter of a liquid is, like maybe it's surface tension, but not quite. Could we make a liquid that is denser that wants to go to the center, and a liquid that's essentially lighter and it wants to go to the outside? So I'm imagine you're in space and you had, you can't mix oil and water. So if you were to have an orb of water floating in space, and then you took an eyedropper and then you put a drop of oil, the oil is denser. And so I think the oil would go to the center of the sphere. So can you do that with liquid? I think we can just use a liquid emitter here. Sphere packing grid. Yeah, that's all good. We are going to go in 0G. So simulation scene 0. Under liquids, I think all this is fine. So let's just hit play. Send a liquid emitter, a liquid group. It is possible. Actually, does anybody know this? Because I don't think I've tried. If I'm rendering, is it eating up the simulation engine that's running in the background, which means I can't run simulations while we're rendering? I've never tried that. Or am I just using the liquid emitter wrong? If I hit play on a regular emitter, oh, that emits particles. So why? I just made a regular old liquid emitter. Oh, it needs geometry. My mistake. Okay, sphere. Okay. That was my mistake. Okay, so there's a blob. It does an excellent job of filling up. Okay, so it doesn't need to be anywhere near as large. Shrink that down. And then, how do I want to do this? I think maybe we'll just make a copy of the whole thing. Now scoot off to the side. And this one, okay, hang on. It's not cooperating. Okay, I made accidentally too many. Let's show the sphere. Okay, so now I've got a duplicate of the rig, and I'm going to move it up into the air. And so we've got a separate sphere, and this one doesn't need as much liquid, so we're going to shrink that down. And we're going to change the color to be something very different. So we'll go lime green and just saturate. Okay, these are going to be horrible colors, but at least we'll be able to see them. Okay, so identical. Now, this liquid emitter is going to initialize with whatever properties it has here. So target density, I kind of feel like is maybe the magical property here. So I'm going to say that this, let's tell this one that it's 1/10 of the density. friction, stickiness. Everything else seems normal-ish. Now, if these bump into each other, do the liquids instantly interact with each other? That is an open question. I'm going to slightly intersect them. Okay. So, let's see what that does. They're just orbs. That's not really doing much of anything. I think they're supposed to interact kind of out of the gate. I'm going to lower that down so they're more intermingled. Do the liquid sims not interact? Maybe they both need to go to the same particle group? I don't know. There might be settings for this. Emission, particle group. So I'll say that they both go into that other particle group. So this one doesn't even exist. They should still have their own colors. Yes, maybe not. Those do not feel like. Actually, that's super interesting. Does it look like to you that the second one? Oh, interesting. That's interesting. Only a single frame forward, and suddenly I pushed them all away. Yeah, that's interesting. They're not reacting to each other. Okay. Is there a setting for that? Simulation scene constraints, because there is mixture ID, but they're both 0. Yeah, I mean, what I was hoping to see happen was one's going to glom onto the other one. That we're going to see this one be like, oh, there's a blob here. I want to blob onto it, and I wanted to see if the green stuck with the green, if the purple stuck with the purple. But they are, as far as I can tell, acting as independent blobs that are not surface tensioning into each other. I'm going to crank those numbers up. Blurp. The purple one's kind of getting pulled up, but the green's got less density and is just going bananas. What are you doing, green? That's the only difference, is it has less density. I guess we will give it a bit more than double, but only a fourth of what the other one has. I might give this a extra iteration. No difference. Extra viscosity and surface tension iteration. Marginally better, maybe. Let's see. Okay, I was checking the chat to see if anybody had any suggestions, but I don't see any. Okay, I'm just curious. Let's reset that to the same viscosity. So they should be identical. I just want to see what happens. So, okay, they're behaving together. That one's already intermingled. But, now are they just acting like they're not blobbing together the way I think they would? Yeah. Okay. Well, I'm not making a lot of progress on this. It's one of those kind of technical questions that kind of fascinates me. Too much. Calm down. Yeah. So get a little bit of something going here. Blob. Yeah, those are just fully intermingled, so they're not kind of free to move around. Like obviously it's trying to hold on, but I mean, if it's on the outside, but then the surface tensional one, I don't know. They don't. I'd have to think about it more, because it kind of makes sense that one. Like, I want them to be attracted to each other, but not. I guess I want them to be attracted to each other, but not share each other's like viscosities. So they are doing their own each other's viscosity. So maybe, and I don't know what mixture ID means, but if I say mixture ID 1, does that mean they are now separate liquids? Yeah, okay, so it definitely was a different behavior. So now I don't know for sure, but I think they are acting as if they are separate liquids. So if I made them be separate liquids but be attracted to each other, and then one is denser than the other, see, that's starting to make more sense to me. So if I double the density of the green one, so that's going to be a thicker blob. And yeah, it's denser, so you see it yanked away some of the purple because it's heavier. And then I'm going to weaken the target density of that one. And actually, I'm going to reset those surface tensions. Yeah, so the only thing, density is a little different, and they have different mixture IDs. So now you see this one's weaker, so it kind of got exploded out of the way. Now I actually might increase the viscosity to 0.5, 0.5 on the green one. So it wants to be a proper blob. And let's scoot it higher. And it's got way more density. And the turbulence, I mean, the turbulence is just kind of adding in some chaos in the scene, not necessarily a bad thing. But now, can we, if I just make an attractor, that would kind of work. But I'm more thinking we want some, would it be predator prey or some flocking to make the particles all be attracted to each other? Maybe? Maybe. Dangerous stuff. Dangerous stuff. Let's see. Okay, so actually, we can turn off turbulence. I want to see only the attraction do something. So I wanted to see if these two will get attracted to each other. This radius maybe needs to go larger. Ooh, that's 500. Yeah. Okay. There's movement. They are attracted to each other. More frames. Gently moving towards each other. Now that green one is a lot heavier. It's a denser material. So they're getting attracted to each other. And in theory, okay, good so far. It's accelerating in. And because it's denser, they're attracted equally. But this one has to give way to what that one wants to do. And this one's going to keep getting pulled further and further in until there's an equal number of the purple ones around everywhere. The whole thing is getting yanked downward, mostly because it's probably a heavier density. And this is maybe not respecting density. Actually, it would make sense it's not respecting density. So they're all getting attracted to each other, but this one's allowed to push a lot harder on that one. So I'd probably have to counteract that effect. But it's not wrong so far. And I mean, it's hard to tell, but I'm pretty sure. Oh yeah, they're both in the same group. Yeah, I'm pretty sure this is hollow. Yeah, it's got to be hollow except for where the green is, and then the viscosity of this outer one is going to keep slowing down. I mean, it's kind of working. I'm just trying to think of a way of making it better because it's traveling quite far down. That having more density works for me. But flocking doesn't have any sort of density multiplier because the density is a property of the liquid. Yeah, fried pixels, I don't disagree, but keep in mind we are rendering at the same time. Let's see how that's looking. Whee! It is not rendered all that much more. Well, like I said, I forgot to lower the quality, so yeah, you can see that any given frame is actually taking a while to chug along. So I'm kind of feeling, well, yeah, can we lower the viscosity even more? I want this to be, okay, this is 25% of what the original value would have been. Oh, wait, that's that one. That's 5 times the original. This is 1/4 the original now. And then this is the purple one. So we can give it some speed, traveling up Y, 200 units. So that's going to fling it upward a little bit. And then we'll see what happens. And then the flocking, I'm going to increase the strength. I'll triple the strength and ever so slightly increase the separation just so they don't collapse in on themselves. Quite a large radius. Although, is it that large? Yeah, the sphere, the small sphere is about 30, so it's big enough. Okay, wow, okay. Oh, well, that's me flinging it up with a lot of force. I fling up so much that it's overcoming the density a little bit. Okay, let's give it some... It's not bad. Let's fling a little less. Also, I'm going to grab the purple one and move it below. The object is lower. I like it being lower in the object manager as well. Delete. Half the speed upward. And then this might benefit from a liquid mesh. Glurb. I guess they weren't really interacting before, but it's just a mesh. They would have to be separate meshes to make this work. I mean, bloop. It kind of looks like it worked. Let's turn off the liquid mesh. Yeah, it's in there. And you see the top is flat, but given a little bit of time, that should turn into a perfect sphere. I mean, oh yeah, and turbulence is turned off. And that, yeah, this guy just is going to want to float around in there. I think that all makes sense. Yeah, okay, and now here's the next test. Yeah, here's the next test. How do I do this? Let's make that visible again. Okay, we're going to take this one, and we're going to shrink it down a little bit, not too much. And we'll make sure they're not quite intersecting. But then I'm going to put that into a connect. I'm going to make a cube as well. Shrink it down. Just for fun. I'm going to put this cube over here. And we're going to do the same thing on this one. And let's see, where do I want that? I'm going to make a second blob up here. Okay, so now purple here, green here. And then in theory, these will all get attracted to each other. Well, this one, we got to be careful with that speed. I flung it upward because it would just make them interact quicker. But now that would be a detriment in here because they're kind of separate. But I just want to see. I want to see if the greens will merge into each other, and if the purple will merge into each other. Like, that'd be really interesting. So let's make sure that we are connecting and connect. So they're looking at the proper objects now. Hide. Okay. Let me save because it's a cool experiment. I like it. 3A. Unmixable liquid. All right. I should probably also make this one a little smaller. Okay. Blurp. Okay, so we get these blobs. Interestingly, okay, those immediately get attracted. It'd be really cool if that goes in the center of that one and this goes in the center of that one, and then the two of them end up blending into each other. Although that's accelerating away pretty fast. Yeah, okay, they're going away a little too fast. I don't want to crank up this flocking too strong or too far. but I will if I have to. Okay, just really large radiuses on that. So the hope here would be, yeah, everything's getting pulled toward the center. Okay, it's working. I just don't want it too strong. And actually, it is quite strong. So I'm going to lower 2, 3, no, 1, 2, 1. Yeah. Okay, that's enough for them to attract. Purple, purple. Lovely so far, pretty much perfect. Purples look like they're just merging into each other. Greens are fighting. There's purples in between them. So the greens might have a little bit harder of a job here. But those are doing a great job. It's almost a perfect sphere already. The green ones are a little more resistant, but at a glance, not bad. Hard to tell. Yeah, hard to tell if there's the purples trapped in between the two of them. But yeah, these purples, I think that's pretty good evidence. The only problem we have is this green is not blobbing too much. That's these. And they actually have extra viscosity. I would think that, yeah, that is the green. Interaction mass. Oh, that's interesting. Interaction mass. That might be for other things. But if we gave it a lot more interaction mass, I wonder if that would change. Because right now we're doing target densities. Ease in. Yeah, those are surprisingly resistant to blob into each other. I might turn on some turbulence here. Yeah, I'll turn on that turbulence just so there's a little extra something in the scene. Yeah, the purple's doing such a great job. That was the extra density. Curious. Like they blob in so nice. I'm a little confused. Okay, I'm going to copy all of those parameters from the purple one, and we're going to paste them onto the green one. Change the mixture ID. And, well, let's just, okay, here, they're going to have the same density to start out with. I just want to see what that means, because, you know, there's no reason that the greens should win the battle. Yeah, they'll just squish each other exactly equally. Now, the purples and the greens, I don't think want to mix, but they're just, you know, they're just two liquids that are like able to like interweave with each other. So then we introduce something like the green having like 4 times the surface tension. And I don't know if they reinitialize, if the green is going to fight to get into that position, etc. But let's just do that. I don't know if I have to reset, because you see there's no keyframes here. So this might just be like the initialized parameter. So, okay, already just with that viscosity, very different behavior there. But they don't weigh any more than the other. So they're more resistant to changing shape, but they are no more dense. So I'm going to put that 25 back in there. So now they are just as squishable, but we're going to increase their density. Actually, no, I'm going to leave their density, but we're going to try increasing their interaction mass, which is now way higher. I just want to see if interaction mass works on liquid. So is this going to crash through purple? No, it doesn't. No, I don't think it is. They're still squishing into each other just like they were before. So interaction mass is not for liquid on liquid. It's probably how heavy is this liquid if it's colliding into like a rigid body or a rope. So now it really does turn into just the target density was the only other major difference. So if I say it's twice as dense and we run it again, is that single-handedly going to like that? Now it's smashing the purple out of the way just by changing the density. And you see the green is able to smash right through where they're both, you know, equally attracted there. And just by copying the other settings, which is mostly the viscosity and surface tension, it is blobbing together a lot better. Yeah, there you go. That's pretty much the effect I was looking for, right? And this is even, I mean, that's pretty much perfect, right? I'm actually quite pleased with that. Okay, to finish off the experiment, because I think we're over, yeah. But what I want to do, how do we do this? What I want to see is these two blob into each other and these two blob into each other before they merge into the whole, if you know what I mean. Cube and sphere. So yeah, if we separate these out a little bit more, I might have to increase the range more, but I think I think this flocking is already encompassing every particle. So by increasing the radius, they should all just get attracted. And we don't need that much strength. We already saw the strength was quite high. So let's say 0.5, 0.5, 1. Okay, so the hope here is these will get attracted to each other. These will get attracted to each other. And overall, the entire system wants to blend in. I want to see the green go into the purple, and then the green go into the purple, and then all of them merge, and the green meet the green, and the purple meet the purple. And if that works, I'd say successful test. I'm going to save and run. They are getting attracted to each other a lot more than, or Okay, I got a hack for this. We are going to make 2 flocks, and I'm going to turn off that one, which is big, and this one we're going to lower it down to be way smaller. Okay, so we're going to start, and I'll just turn it on. Hopefully, turning on will work. So these should be close enough that they want the blob. These should be close enough that they want the blob, but they're too far apart from each other. Okay, I mean, pretty much that's exactly what I want to have happen, right? Like, and this is pure physics happening now. I don't know if it's the purple is trying to eat the green, or if the green's like, nope, I'm gonna. It's looking for. It's trying to get warmth, like inside the tauntaun. It looks like the attraction is beginning a little bit between the two of them. Maybe it's just the way that there's not that much purple liquid up here, so maybe it's a little. The viscosity is not weak enough. Maybe I can change that. Although it probably has to reset again. I'm going to say that they're less than half as viscous as they are. So the purple should be very blobby. So this will have very little self-cohesion. So I think it would wrap around more easily. And already seems to be the case. Cool. Come on. Blend. Blend. I think given a little bit of time, it will. Yeah, it's getting there. That's cool. I like it. Yeah, a little more purple liquid would have gone a long way there. It is doing it. And based on the way the settings are, I think that given a little bit of time, they would blend. But I'm going to reactivate. I'm going to activate this one, and immediately see they start getting attracted towards each other. I can actually turn it on and off and just get them accelerating towards each other the speed I want. Now I've turned it off, so now now they're on a collision path, which is pretty much what I was looking for. Oh, they lost their velocity. That's interesting. Well, anyway, I can just turn it back on again and say no. Charge towards each other. Almost completely closed. Come on, do it. Oh no, not quite completely, but more so. It is still doing it, just slowly. It's just seeing more purple. Okay, nice. Crash. I'm zooming in so the relative particles are larger. Purples have merged with purples. These two are trying to get the center of mass. There might be some purples in between that are sort of blocking them. Maybe not. But it's doing an okay job. They're starting to look like one blob. All right. I would call that a successful test. Look at that. That's really cool. Blurp. We would need both of these to be treated as separate meshes so we could kind of make one mesh and make a different mesh as they blobbed in. But I think that would actually be pretty cool. So density seemed to be the biggest. We say they don't mix with each other, different densities, and then we used the flocking to act as like a just gravity on gravity for everything. But yeah, I'm quite pleased with the way that looked. Any questions? Because like I said, we're already over here. I'm going to throw a render display use lines. So those are there. So if somebody opens up the scene file, there's actually something to see. Yeah, Zach, I think you could probably reverse the. Well, oh no, actually, that's a really good point. Oh, now you're making me want to try. If we did let them blob, if we let them blob into each other, and I took a wedge shape and I shoved the wedge in between the two, in theory, they would split, and then the purple would recoalesce around the green, and they would. You could sort of do cell division that way. Yeah, I'm trying to think of a way you could get fancier than that. There's something more dynamic. Because you could, in theory, also have the particles emitting slowly. So it's kind of like there could be more purple and more green. And once they hit a certain threshold, suddenly they'd want to split. I can't immediately think of a way to being like half of them should split this way, half should split that way, and want to pull in different directions. But, with some work, maybe a rig like that could be built. But I don't see any reason why. I think we could chop them in half with a wedge. And if those two parts got far enough away from each other, they would just reblob properly into themselves. So yeah, that could be kind of cool. I mean, honestly, there's so many different elements to this because it's like if we made a whole bunch of little versions all over the place of this, like in theory, we could just put more shapes here where it's like we could have dozens of blobs of them all over the place, like little droplets. Each one, there could be just green, there could be just purple, and a bunch of them where it's green and purple, and then they would eventually all coalesce into each other and eventually form one giant blob. We proved it with 2, but you could do it with as many as you like. Pretty cool. I guess we'll check out the render, which didn't get that much further, but we might as well. Yeah, starting to get the bokeh effects as it gets closer to the camera. Or is it bokeh? Is it bokeh? I think it might be bokeh. Yeah, it looks. I was definitely getting the blur going when it's more in this type of environment, but honestly, I kind of like the pre-blur or pre-glow. Like this color's a little more vibrant. Everything's getting a little washed out once you suddenly see the blur kick in. And overblown, blown out. Very cool. All right, that was an exciting one. Got to show off the interconnect. Excellent question with the rope creating stuff, and yeah, unmixable liquids. Kind of proof of concept. Very cool as well. Jonathan Wimbush. We were trying to make them not be able to mix. That was the goal of having like oil and water. So water could mix with water, the oil could mix with oil, and we didn't want them to be able to mix with each other. So that was the experiment on that one. But that I think is going to wrap this one up. We went a little bit over, but hey, we're talking about cool stuff. Thank you so much, everybody, for watching. If you want to get access to these scene files or support Rocket Lasso, you can go and support us on Patreon. Just search Patreon and the word Rocket Lasso, and you should find it pretty easily. Yep, next week, I think, regular episode. There's not going to be that many more season or episodes in the season. Half Res is coming up in less than 2 months. So, in the month of Half Res, I tend to wrap up the season. But we'll definitely be back next week. Thank you so much, everybody, for coming and watching. As always, it is always appreciated. And I suppose until next week, bye-bye.